By early 2024, the internet's primary discovery engines were beginning to choke. A massive, accelerating volume of digital documents was pouring into the system, overwhelming the pipelines users relied on to find information. This was the peak of lazy automation. The barrier to entry for content creation had collapsed, allowing anyone with a basic script to produce thousands of articles with almost no human oversight. These auto-bloggers relied on blunt force tactics. They used automated scrapers to lift text from legitimate sites and fed it through basic LLMs to swap words, creating infinite clones of existing information. Between 2024 and 2025, the volume of synthetic content didn't just grow, it spiked vertically, burying human-authored articles under machine-generated noise. This second line shows the result. Search utility plummeted. The probability of finding a verified source fell toward zero. By late 2025, search engines saw a measurable shift in user behavior. Click-through rates on organic results dropped as users migrated queries toward closed communities and social forums to find answers they could trust. Because the business model of search depends on the commercial value of those clicks, the flood of synthetic content made the existing index economically unviable. To maintain their market position, search companies had to engineer a systemic, highly aggressive response to clear the noise. This led to the 2026 digital landscape, a hyper-policed environment where every piece of incoming data is treated as a potential threat. Search providers abandoned the slow, reactive filtering of the past. They implemented a structural shift that moved the gatekeeping process to the very edge of the network. They deployed specialized neural networks designed for one task: instant identification. These are the millisecond executioners. While previous algorithms took days to crawl and categorize a site, these systems evaluate the DNA of a web page in the time it takes to load a single image. This flowchart illustrates the diagnostic logic. When an article is submitted to the index, it is instantly split into parallel streams that scan for different markers of automation. The first stream focuses on syntax. It identifies the predictable, repetitive sentence structures and the safe generative phrasing that dominated the lazy automation era. Simultaneously, a semantic stream maps the actual depth of the claims. It flags hollow nodes, content that uses a lot of words to say nothing new, offering zero unique value to the index. If the patterns match, the penalty is instant. The article is assigned a zero-weight score, effectively deleting it from the searchable web before a single user ever sees it. This makes the tactics used in 2024 entirely obsolete. The slow-moving game of cat and mouse has been replaced by a wall of high-speed, automated judgment. By making low-effort AI content instantly identifiable, search engines restored order to the index. For a moment, the era of the auto-blogger seemed to be over. However, the developers of these automated systems did not stop. They pivoted toward a strategy of total evasion, looking for ways to move beneath the detection threshold of the new neural networks. In early 2026, the Autoblog Empire software released a major patch designed specifically to counter these millisecond executioners. The developers claim this update produces content that leaves no measurable digital footprint, allowing automated sites to remain invisible to the syntax and semantic scans. Their strategy targets algorithmic shadows, the narrow intersection between what machines consider human and the patterns of organic writing. The software routes its output through these shadows, mimicking human inconsistencies to avoid triggering automated red flags. At this stage, we lack the domain performance data or patch notes to verify if these evasion tactics actually work. Without hard evidence of these sites ranking in 2026, the software's effectiveness remains an unproven theory. The conflict has moved into a cycle of high-level engineering and counter-engineering. The future of information discovery now rests on whether neural networks can eventually learn to identify these human-like machine patterns as easily as they crushed the lazy spam of the past.